Hello, this is Captain Chaudhari. In a series of videos on marine astronomical navigation, today I am going to discuss this formula for meridional zenith distance. It is equal to L difference D, same name subtract, different name add. Now, I've seen some boys they do, site calculation with a formula whereby we don't use this principle L difference D, same name subtract, different name add. But a candidate must know that for the upper meridian passage, whenever a body crosses the upper meridian, at that time the zenith distance is given by L difference D, same name subtract, different name add. Different name in the sense like suppose the latitude is south and declination is north. We will add the declination with latitude to get the meridional zenith distance. Right? So here you can see that we will subtract the declination from the latitude to get the zenith distance. Here we'll add the latitude and declination to get the zenith distance. Now it is given by a simple equation, that is L difference D is meridional zenith distance, same name subtract, different names add. So whether the candidate knows about this particular relationship will be known by this numerical that I'm going to do with you. Now it says that there is an observer at North Pole. He finds a star at altitude of 21 degrees. Now if the observer is at North Pole, and if I draw a celestial sphere diagram, and if the observer is at North Pole, North celestial pole is also observer's zenith, then I would say the great circle 90 degrees away from the celestial pole should be equinoctial, and great circle 90 degrees away from the observer's zenith should be observer's rational horizon. It means that observer's rational horizon and the equinoctial are the same great circle. I am viewing the celestial sphere from top of the observer's zenith or from top of the north celestial pole. If the star is seen at an altitude, the altitude is the distance from the horizon, right? So if it is seen at an altitude of 21 degrees, I would say that the star is also at an angular distance of 21 degrees from equinoctial. And because this is not celestial pole, I would say the star's declination is 21 degrees north. And this star does not change altitude. This star will go on a circle which is maintaining the constant distance from the equinoctial, right? The star would be seen moving like this. So this particular information is given to you that an observer at North Pole sees a star at an altitude of 21 degrees. This statement means only one thing. It means that the declination of a star was 21 degrees north. Now the question that is asked is, what are the two latitudes, or what are the latitudes in which the meridian passage altitude is twice this? That means 42 degrees. The altitude at the time of meridian passage, as you know, is the maximum, and it is 42 degrees. The maximum altitude is 42 degrees. That is the question. So if the maximum altitude is 42 degrees, I would say meridional zenith distance is 48 degrees. So I want to find out what are the latitudes in which the zenith distance is 48 degrees. Now let us assume that in a slightly loose language, we talk about upper or lower meridian passage. We will consider both, and I will make a chart of this. One is about lower meridian passage and other possibilities about the upper meridian passage. Lower meridian passage, if the meridional zenith distance is 48 or meridian altitude is 42 degrees, we have the formula L plus D minus 90 is equal to lower meridian altitude, which means that latitude plus 21 minus 90 is equal to 42. That is the meridian altitude, right? Which means that latitude is equal to 90 plus 42 minus 21. That is, latitude is equal to 111 degrees, right? Which is not possible. Upper meridian passage, there are two situations. One is latitude and declination, same name, and other one is latitude and declination, different name. When the latitude and declination are same name, the difference, and when latitude and declination are different name, the sum. So difference, it is L difference D, which should be equal to meridional zenith distance, that is 48 degrees. Either it is L minus D or it is D minus L. D minus L is not possible because declination is only 21 degrees, so L minus D. So L minus 21 is 48, which means the latitude should be 69 degrees, and we are talking about the same name, so 69 degrees north. That is one possibility. And the other possibility is where latitude plus declination is equal to 48 degrees. We know declination is 21 degrees, so what should be the latitude? So that the total is 48 degrees. So latitude will be 27 degrees north. So in this case, lower meridian passage, this particular thing is not possible, that the altitude is 42 degrees, but upper meridian passages, there are two latitudes. These are the two remote latitudes on which at the time of meridian passage it would be found that the meridional altitude is 42 degrees or meridional zenith distance is 48 degrees. We will see how it can be possible through the diagrams. So one situation is 69 degrees north. We write down V, north, south, Z. 69 degrees north means the equinoctial comes very low like this. This is Q, and from here to here is 69 degrees. And the declination, because it is 21 degrees, you will find that the body travels like this. This distance is 21 degrees. So you will see that the remaining distance, that is the zenith distance, at the time of meridian passage is 48 degrees. And if zenith distance is 48 degrees, the meridian altitude will be 42 degrees. Right? So this is one possibility. Let's look at the other possibility. Other possibility is when the latitude and declinations are different name, and latitude, it seems, is 27 degrees, it should be south, 27 degrees south, because we are talking about latitude and declination being different name. Declination is 21 degrees north, so latitude is 27 degrees south. So this is Z. 27 degrees south means something like this. The equinoctial will be over here, WQE. And because the declination is 21 degrees north, we have the apparent daily path this way, and at the time of meridian passage, this is 21 degrees and this is 27 degrees. Total meridional zenith distance is 48 degrees and meridian altitude is 42 degrees. So you can see that there is one observer somewhere in south latitude, 27 degrees south, and there is another observer in 69 degrees north. Both these observers at the same instant, right? Both these observers at the same, if they are on the same meridian, at the same instant, they will find that the meridian altitude of this star is 42 degrees.